Okay, we're going to give this a try. Welcome to your first digital session of ECON 309, Economic Problems and Public Policy. I hope everyone is safe and comfortable and healthy wherever you may be. Just a few organizational things before we start the lecture proper. Sorry, just wanted to have that for later. So thing number one, the way the class is going to work is every week, probably on Tuesday, maybe early Wednesday, I'm going to post a video like this where I'm going to be lecturing as if I was in class. It'll be a little bit shorter than the class because there won't be any kind of student feedback or discussion going on. So to compensate for that, attached to each video lecture, there'll be a little Blackboard discussion board, or I might just have it where you can comment directly on the video, where you can ask questions. And then probably on Fridays, I'll make another video of myself reading and answering your questions. And so the way participation grading is going to work is you just need to have participated in those discussion boards, asked a question, at least, 2 or 3 times by the end of the semester. So that's the idea with that. Thing number 2, the midterms, those are due. Those haven't been due yet when I'm recording it. It's 4 o'clock on Tuesday, so they're not due till midnight tonight. I will say, please don't worry about the raw grade you see on Blackboard. That hasn't been curved yet. Some people did pretty well. Other people had a lot of trouble. I totally understand. I must have asked some pretty hard questions. But also I understand that the exam wasn't taken in the most ideal of circumstances, right? First it was pushed back a week thanks to the extra week of spring break, and then with all the madness over coronavirus happening, trying to figure out where you're going to live, what's going to happen with classes, I completely understand if it wasn't the most ideal circumstance for taking the exam. So once I get the rest of the grades in and I see what the grades look like with a curve, I'll get back to you. I might have some way for you to earn some points back. So maybe have you do test corrections, or I might have like a live stream Blackboard Connect or Zoom meeting that you can tune into and ask questions about your exam and maybe earn some points back. So it's a really stressful world right now, so I just want to make sure that this class is not high up on your stress meter right now. And I think that's pretty much it. The third paper, so the reason this says week 10 instead of this is technically supposed to be week 9, I think. But the reason for that discrepancy is because this presentation will contain the information for the third paper topic. It'll still be due in probably 3 weeks. I'm thinking mid to end April. Probably the second to last Tuesday in April is when we'll have it be due. So I just want to get that topic out as soon as possible so that you guys can manage your schedules. If you have any questions about organizational stuff, just feel free to post it in the discussion for this video, or email me, but I prefer you to do the discussion so that other students can see what questions have already been asked and answered rather than me getting 10 emails and then responding 10 times. Okay, so let's get started. So the main theme for the lecture we're going to be doing today is going to be attached to your final paper, right? So you may remember your final paper in this class is going to be kind of a literature review / synthesis of literature on a public policy issue of your choosing, from an economic perspective, obviously. So in order to write that paper, you're definitely going to have to read a lot of existing empirical policy research. So what we want to look into today is how do people go out and actually answer empirical questions in public policy. What's the effect of X on Y? How can we tell what the effects of this policy were? How do we answer those questions? What are some pitfalls that bad policy research can fall into? And how can we weigh when two studies come to different conclusions, how can we judge which one is closer to the truth? Okay. I apologize for any noises. Obviously, I'm not just the only one stuck in this apartment. My wife is working from home. My daughter is also working on growing teeth, so she might be complaining in the background. So, sorry. Okay, so let's start with the first place any discussion of empirical policy research starts with a really, hard-hitting, really techy, wonky subject, and that's Gordon Ramsay's Kitchen Nightmares. So this is a show that would actually probably make really good quarantine viewing. You can remember what it's like to go to restaurants and interact with people. But the main premise of the show is that this angry British man, he visits restaurants that are on the brink of failing. They're about to go under. And first he tries all their food. He makes a bunch of bad puns and rude comments about the food.
People really like them.
Yeah, half the customers are drunk. I don't even think he likes the war.
If that's beef, then hey, I was born in Bangladesh.
They've got it wrong on the menu. It's not a crab cake. It's a crab cake.
Musaka, that is miles off. Musaka.
Musaka. Seafood crepe. Yeah, that's seafood crab.
Take a bite of that cod. It's almost like you've got a breaded condom in your mouth. Oof.
Can I get you anything? No?
Sit back. I've just been left out for days.
Forgot how this was. Okay, so then at the end of everything, he renovates the restaurant and does a new menu. And they play this really hopeful music. And he leaves, and the implication is that, the restaurant is no longer going to fail. Now it's going to be successful. Okay, so this is an example of a policy intervention. All right, we have an outcome that we're interested in, that being restaurants failing or not failing, and we have a treatment. All right, treatment is some policy that's going to come in and affect things. We're interested in the effect of the policy. So the treatment, the policy in this case, is a blonde-haired British man coming into your restaurant, making bad puns about the food, and then making all these interventions, fixing the menu, fixing the decor, etc. All right, so if you were to ask, a high schooler, right, how can we figure out whether or not the policy worked? Maybe the first idea he or she would come up with is let's see what percentage of the restaurants that he visits end up closing. Okay, so I tracked this information down. You see that of the 77 restaurants that he visited and did his policy on, 30 were still open, so about 40% of them were still open. So 40% of them still open, 60% closed. All right, and within 1 year of the episode airing, about a third of them closed. All right, so you could read this and say, okay, so, you've got failing restaurants that you come visit, and then 40% of them go on to be successful. So, hey, the policy saves restaurants 40% of the time. It's like a drug that saves your life 40% of the time. All right, so think about this. And tell me, or not tell me, because you can't speak to me, but think about what's the problem with this interpretation of thinking about, of seeing these numbers and saying this policy is like a drug that saves your life 40% of the time. And the answer that you'll probably think of is that we don't know what would have happened to those restaurants without the treatment, right? We can only observe what has happened with Gordon Ramsay coming and yelling about your food and fixing the menu and all that, right? It could very well be the case that had Gordon Ramsay not shown up, some of these restaurants might have figured things out on their own, or maybe they would have not closed down even with their terrible food, right? We just don't know what would have happened if not for the treatment, okay? And this idea of the road not taken, the outcome that we don't observe, that we can't observe, economists call that the counterfactual, all right? And this is really important because when it comes down to it, all policy analysis is counterfactual analysis. It's saying, we can easily observe what happened. What's really hard is observing what didn't happen and looking at the difference between those two things, all right? Because if we imagine that we have, some crystal ball or some psychic, right, that can tell us, oh, this restaurant, if Gordon Ramsay didn't intervene, this one would have stayed open. They would have, changed the menu on their own. This one, they would have closed without his intervention. This one, they would have just persisted with their bad food, stuff like that, right? If we had that information, it would be really, really easy to calculate the effect of the treatment, right? Because we look at what actually happened. Let's say, 40% of them stayed open with the treatment. We know that. We observed that in previous slides. And using our crystal ball, we learned that, 30% of them would have closed without 30% of them would have stayed open without the treatment. Okay, so we can really easily say, 10% I'm gonna get rid of that. You're going to have to bear with me as I learn how to best do this. I'm thinking of ordering a whiteboard that I can write on, but okay. So 40% actually stayed open. Okay, we know that from the data. And then 30% would have stayed open. That's in blue because it's from our crystal ball, right? And if that's true, then you've got a positive 10% chance of survival. The policy makes you 10% more likely to survive. All right? So what we need to think about now is, since we don't have a crystal ball, what can we use to kind of estimate this number? Okay? And the good thing, or something that's usually good when you're analyzing policy, is that Gordon Ramsay doesn't go to every restaurant, right? There are plenty of restaurants, most restaurants operate without getting the treatment. They operate without ever having him come and yell about the food. All right, so why don't we say that, when we want to estimate this number, let's look at all restaurants, okay? And when we look at that, we can just look at, I just looked up a study, and in general, 40% of restaurants, 40% of restaurants are still open after 3 years. Okay, so that's the number we're going to use, okay? So we can say 38%, I was rounding in the previous slide, 38% of Kitchen Nightmares restaurants are still open without the treatment, or with the treatment, right? And then we say, okay, well, looking at all other restaurants, 40% of them are still open and they didn't get the treatment. So it seems like that number is actually negative. So it makes you 2% less likely to survive, okay? The restaurants that Gordon Ramsay did go to are 2% less likely to stay open than restaurants that he didn't go to and help. Okay, so that triumphant music was wrong. We thought he was helping. He's actually making things worse. Okay, so our previous interpretation, that's like I said high schooler, but this is maybe even a middle schooler. Okay, right? This might be what a high schooler or like a college freshman would come up with. Okay, so here's our conclusion. The policy makes restaurants 2% more likely to fail. Okay, so what's wrong with this interpretation? All right, so it's pretty clear that we can't just have no counterfactual. All right, the problem here, hopefully you're thinking, is that we probably chose the wrong counterfactual. All right, so our counterfactual, our stand-in for that crystal ball number was the outcomes of just all restaurants in general. Okay, but the kind of assumption we're making here is that the average restaurant is a good stand-in for the outcomes of the restaurants that were featured on Kitchen Nightmares had they not been featured on Kitchen Nightmares. Okay? And the problem is that that's not true, right? Gordon Ramsay doesn't visit restaurants just at random, right? He doesn't just walk down the street and pick out a random restaurant to walk into, right? How does he decide which restaurants he visits? Well, he goes to the restaurants that are close to failing, right? He wants to be able to make fun of the food and help the management and spruce up the decor, right? The thing is, the things that make Gordon Ramsay go to a restaurant also make the restaurant more likely to fail. Okay, so we have these variables, right? Food and management, right? That are correlated with the treatment, right? These things help determine which restaurants get the treatment, but they also determine the outcome, okay? And that's a big problem, okay? So we have this problem where the outcome influences whether or not you receive the treatment in the first place, all right? And economists call this an endogeneity problem. So, okay, sorry. So endogenous, right, that means coming from within a system, right? And you can think about, the treatment and the outcome as being tangled up, right? So another example of an endogeneity problem would be, let's say we look at, I'm going to post a lecture here that you should watch maybe 10, 15 minutes of, but a professor at Mason, Tim Grosclose, he's really interested in does watching biased news, just watching Fox News make you more Republican, vote more Republican, or just watching MSNBC make you vote more Democratic. And the simple-minded way to do this would just be to see how Fox News voters vote and see how MSNBC voters vote. But the problem is, again, there's endogeneity. It may be that what you watch, so that's your treatment, right, determines how you vote, your outcome, but also how you vote is tangled up with what you watch, right? Republicans like to watch Fox News because it confirms all of their previous biases, right? Same for Democrats and MSNBC. So there's no way to know just looking at the world as it is, doing an observational study, right? What's the actual causal effect, whether or not Fox News is causing people to vote Republican. Okay, so that's another example of an endogeneity problem. All right, let's look at another example. Okay, so this is a study published by doctors. This is in a medical journal, and they want to know whether watching TV as a kid is going to give you ADHD as a preteen. Okay, so my daughter's in the other room. She's been watching a lot of TV kind of secondhand. She's not really old enough to appreciate Barney or anything, but trapped in quarantine, we have the TV on a lot. Are we going to have to give her a prescription for Adderall in 6 years? Okay, so this is important to me, maybe important to you who are parents or thinking of becoming parents, whatever. Okay, so let's look at their research method. Okay, so they had a data set. This is a great data set, the National Longitudinal Survey of Youth. Basically, the methodology is they have a group of people and they interview them at different points in their life. Okay, so if you were a participant, they would interview you at age 3 and ask all of these questions about any topic you can possibly think of. And then a year later, they'd ask you all those same questions, and a year later, and a year later, and they would do this throughout their entire life. Okay, so there's one cohort of the study where they started interviewing them in the 70s, and they were still interviewing them all the way up until the 2000s. There's another one that started in the 90s and is still going today. Okay? So what they did, right, was they interviewed these kids at age 3, and at age 1, and they just asked, at age 1 and age 3, how much TV are you watching? Well, the kids couldn't answer, but they asked the parents, how much television is little Carol watching, right? And they got the answer. And then at age 7, they asked the kid or the parents or the kid's doctor, right, is little Carol diagnosed with any kind of attention deficit disorder? All right. So think about what's the counterfactual? Okay, so we know the treated group are the kids who watch television as kids. We know those are the treated group. So what's the counterfactual? What are we using as a stand-in? Well, so first, what's the counterfactual and the outcome we can't observe? Sorry if that was a little confusing. All right, so the counterfactual here is what would have happened to those kids had you just taken the TV out of the house. Okay, to those specific children. Okay, and we obviously don't have that information, right? Because even if we did take the kids out of the house, well, then we're missing the other point. Now we don't know what their outcomes would be with TV. All right, we can only observe either outcomes with or without TV. We can't observe both at the same time. Okay. What we're using for the comparison group, right, because we don't have access to that, is just the outcomes of kids who didn't watch TV as children. Okay. And remember, that's not the same thing, right? The counterfactual is the outcomes for the specific children who did watch TV had they not watched TV. All right. So that's the counterfactual. The second thing we already said is our comparison group, our stand-in for the counterfactual, and that's just the children that, for whatever reason, watched less TV. All right. And then the third question is there an endogeneity problem here? Okay, so think about that for a little bit. Do we have a similar problem that we had here, where the outcome and whether or not the treatment is received are correlated? All right, and if you think about it, the answer is yes. Okay, because the children who watch TV and the children who don't watch TV were probably different before they ever watched anything, right? Or they're different in ways besides the fact that they watch TV, okay? How might children who watch a lot of TV and children who don't watch a lot of TV be different in ways other than their television viewing habits? Okay, well, children who watch a lot of TV probably have parents who are at work a lot or less involved, right? You kind of have to use the TV as a babysitter, right? Maybe they don't have siblings to play with, or maybe they live in a dangerous area where you can't play outside, right? There are all sorts of things you can think of, right? But those same things that determine whether or not children watch TV could also theoretically influence behavioral problems, right? Maybe parents who are kind of less attentive parents have kids who are less attentive for genetic reasons, or maybe it's an environmental effect. But regardless, right, it's pretty clear that this is not the actual causal effect that we're observing. So they find that, the kids who watched TV had more attentional problems. But if someone showed you this study, it should be pretty obvious that that's probably not the true effect. There's some endogeneity here. Okay, there are all of these confounding variables of, well, the kids who watch a lot of TV also have worse parents, and for that reason, it might look like they have more attentional problems, but that's actually completely unrelated to the television. All right? What we'd like to do, right, is take kids and rather than have them decide who watches TV and who doesn't, because that's what we're doing, right? We're letting the kids and their parents decide whether they get treated or not. We would need some party, ideally we, the researchers, would like to decide, right? We'd like to do a randomized study. We'd like to say, okay, these 50 kids watch TV, these 50 kids don't, and we would pick those people at random. And then we could compare them, right? But the next best thing is we'd like something to determine who is assigned to the treatment that's unrelated to the outcome. Okay, so let's look at another paper, this time by economists. That's why it's better. I'm kidding. I mean, this paper is better, but economists don't always write better papers, only most of the time. Okay, so here what they're doing is rather than just comparing kids who do and don't watch TV, they're going back to when television was first being introduced in the 50s, okay? And they're saying, okay, let's look at, because obviously television didn't show up everywhere at once. It wasn't instantaneous, okay? So their design was, okay, you've got these two counties, right? And in this county, TV started being available in, 1952. And then in this county, for whatever reasons, TV wasn't wired up and ready to go until 1956. Okay, so for those 4 years, the children in this county got to watch TV, and the children in this county didn't. All right, so what we're going to do is we're going to compare the kids we're going to compare people who grew up during those 4 years. Okay, so you can think there's a kid that lives here, there's a kid that lives here. They were kids between 1952 and 1956. We compare them and see, does this kid have more behavioral problems? Okay, so is this design more convincing to you? How is it different from this design in terms of protecting from these endogeneity problems? All right, and you hopefully should see why this is a little bit more robust of a design, right? Because in the last example, we let the subjects themselves decide which group they were going to be in, the treatment group or the control group. Okay, and that's obviously correlated with a ton of stuff. Here, the subjects don't really get to decide. They get to decide where they live, right, in which county they live. But it's the television company that decides which county gets TV first. All right? It's mostly out of their control. Okay, so you can tell a story, right? This isn't as good as a randomized design. Really, we're going to talk later about how randomized designs are the gold standard for finding out policy effects, all right? But this is pretty close, right? Maybe you could say, oh, well, the TV shows up in the richer county first, and the richer county has better parents, right? But that's way more steps removed, right? And that could be true, right? That's something to be concerned about, maybe, but you can see how that's so many more steps removed from this where it's really obvious where the endogeneity is, okay? So when they do this design, they actually find the exact opposite result of this study. So this study, they find that more TV gives you attentional problems. Here they find that watching TV raises average test scores by just a little bit, but definitely doesn't lower them, right? They're able to reject any big negative effects, which is what this study is observing. Okay, so just by changing our research design to better account for endogeneity, we've completely flipped our conclusion. Okay, we've gone from TV rots your brain to TV, if anything, makes you a tiny bit smarter. All right, and they're both looking at the same research question. Okay. So, let's talk about some various ways that we can evaluate policy while avoiding the pitfalls of endogeneity. Okay? So the first option, the one we already talked about, is using a randomized controlled trial. Okay, so for this, we already talked about it. What we do is we the researchers, decide randomly who gets the treatment and who doesn't. So let's say we want to know, does raising the minimum wage cause unemployment? We would randomly say, okay, Fairfax County now has a minimum wage of $10 an hour. Alexandria City has a minimum wage of $8 an hour. Prince William County has 9. Arlington has 11, right? And then we could compare it that way, right? And as long as we picked stuff at random, right, and we had a big sample size, right? It's always important to have a big sample size. We could really easily identify whether or not the minimum wage has negative employment effects, right? Because if we're doing our randomization correctly, there should be no differences between the treated group and the comparison group, all right, just because of the way that randomization works. This is the law of large numbers, right? If you're really randomly picking things, then on average the two distributions should look the same. Okay, this is a kind of a new idea in economics. This is one of the few ways in which economics is lagging behind other sciences. Psychology has been doing randomized controlled trials much longer than econ has. So if you're interested in reading about randomized controlled trials, Vernon Smith is a GMU professor. He's emeritus now, but he won the 2002 Nobel Prize in Economics for doing randomized trials in the lab. So he would take students and he would, randomly assign them to receive different values for goods, and he wanted to measure, whether or not the laws of supply and demand apply, and he found that they did. More recently, the most recent Nobel Prize winners in economics, Banerjee, Duflo, and Kramer, they won their Nobel for applying randomized controlled trials to development. So what they would do is they would say, okay, this village is going to get, or these villages, right, we randomly select a few villages, we're going to give them free water or clean water or malaria nets or whatever they're testing the effect of, and then these villages were randomly not, and that's going to give us a very easy way to measure whether or not these interventions are having the effects that we're interested in. Okay, so why don't we just use randomized controlled trials, I guess is the first question, right? So one is that they're impractical, right? So it can be hard to do, like the minimum wage study that I suggested, right? You would never be able to talk anyone into doing that, right? Although someone really recently did a randomized controlled trial on the minimum wage, but they just did it on one of those websites like MTurk, where you hire people to do like one job. I'm getting sidetracked. Okay, so randomized controlled trials aren't always practical or feasible, right? They're also really expensive, right? You need grants to do randomized controlled trials. But even if you can do one, are they completely foolproof? So think about some ways that randomized controlled trials might be misleading. Okay, so they're the gold standard, but that doesn't mean that just because you see a randomized controlled trial in a paper that you should, immediately say, okay, well, this is obviously an accurate conclusion. Okay, so here's kind of a silly example of how a randomized controlled trial can be misleading.
For instance, a few years ago, Kellogg's was forced to stop airing this ad.
A clinical study showed kids who had a filling breakfast of frosted mini wheat cereal improved their attentiveness by nearly 20%.
Okay, two fun facts there. First, when they say nearly 20%, it's because they're rounding up from 11. And secondly, they were comparing kids who'd eaten cereal with a control group of kids who had no breakfast at all. And that is not so much a case for mini wheats as it is the concept of food. A much fairer slogan would be frosted mini wheats. They're literally better than nothing.
Okay, so that's an example, right? So here the randomized controlled trial chose a really bad comparison group, obviously, right? If we were really interested in finding out the effects of mini wheats, we would have, a group that had unfrosted mini wheats, or a group that had frosted flakes, and a group that had Cheerios, and et cetera, right? So randomized controlled trials can sometimes give faulty results if they're using the wrong control group. There's also a problem of what economists call external validity, not just economists, just scientists in general, right? And this is the problem of maybe the people in our study aren't necessarily a good proxy for the people that we're going to be applying the policy to. So most experimental economics papers are written using undergrads as your subjects, right? You may have gotten an email from the ICES inviting you to do an economic experiment, and you should. It's a great way to find out how this works, and you can earn some money too. Obviously, they're not running now. I don't know why I'm giving you this advice. In the fall, if we're back in the fall, you should go to those events if you're interested. Regardless, where was I? Okay, yes. So they tend to use undergrads as their population that they're studying, right? Maybe undergrads aren't a good proxy for how we're going to, or for the group that we're interested in the policy's effect on. So you can imagine, let's say we're doing we want to see if a micro loan program works, right? It could be that college undergrads are more informed than peasants in Bangladesh, and that could cause some discrepancy, so that even though you see an effect on the microloan for the college students, you wouldn't see it in Bangladesh. That's just an example. But you can think of other examples of external validity. So another example is that for a while, when we did medical experiments, we would only include men. Right? Women were sometimes being excluded from medical experiments. And that led to problems where the treatment would work for men, but it wouldn't work for women. Okay, so that's something to consider when you're doing research. You run into a paper that uses a randomized controlled trial. You need to ask, one, are they choosing the right comparison group within the trial? Right? That's sometimes called internal validity. Right? Is the study itself identifying the effects? And then two is, can we generalize this? That's external validity.
For instance,
We already saw that. I guess that's just a cartoon I put in. It's not even that funny. Okay. Oh, yeah, so there's also another issue. There's the Hawthorne effect. So this is another example of external validity. So sometimes people act differently when they know that they're being observed for an experiment. So it could be that sometimes we do experiments on generosity. We're interested in how generous people are. Maybe when people know that their generosity is being observed, when all eyes are on them, they might act more generous than they would if no one was watching. Okay, so you can see that that's a problem for external validity, right? So maybe we do a lab experiment and people are sharing lots of money with each other. We think, oh, people are really generous, but in the real world, when they're not being observed for an experiment, they're less sensitive to that. So the Hawthorne effect, that's something you can think about and look up. The fallacy of composition is another problem. Not just in randomized controlled trials, actually. I'm not sure why I put this here, but just in general. sometimes an intervention might not be generalizable because it's good for the study participants if you do it to them, but it's not good if you do it for everyone. Okay, so this would be, the example you can think of is, okay, if I do a randomized controlled trial where I randomly give 10 people a fake master's degree, right? They would probably be much better off, right? Because they could fool people and they could get jobs that they're not really qualified for, and they could make more money, stuff like that. If I gave every American a counterfeit master's degree, right, it probably would not be very beneficial at all, right? Because now everyone has a master's degree, and when everyone has a master's degree, nobody does. Okay. I'm going to take a quick break from lecturing, get some water, and then I'll be back to talk about natural experiments.